Right, I think we'll get started. My name is Marcus. I run MS Lighting Design. We're an independent lighting design consultancy, and we're doing a series of webinars. Today, titled this one, 50 Shades of White, we're going to cover color temperature and color rendering. Now, these are some pretty important factors for when you're selecting a light source. It changes a huge amount within the space, how it feels, how it looks. And while there are other important figures to look at, such as brightness of the light source you're using, it's important, really important, to get the color temperature and color rendering right for the project which you're working on. And this can have a dramatic effect. And as lighting designers, we look at this a lot, and we take a vested interest in making sure that we get these right. So what I wanted to do with this webinar is sort of impart some of the basics. It's not going to be very sophisticated. We're not going to go super in depth with the science behind it. It's really those key basics that we look for as lighting designers, what we're trying to work with, and how we make sure that our projects look good, basically. So we're going to start with color temperature. There are a whole range of different color temperatures that you get out there. There's lots of different types. And you want to get the right color temperature for the space. Now, choosing that can be quite difficult. Now, when I talk about color temperature, I'm talking about the white, talking about how white the light is, how warm or cool that light is going to be. But actually, there's quite a lot of nuance within it to determine color temperature. So what we've got here is a basic range of different color temperatures that you've got across the board. Generally, when we're talking about color temperature, we're talking about cool white to warm white. So white with a lot of blue in it, all the way up to white with a lot of orange or yellow in it. And we're going through a whole range. Now, color temperature is measured in kelvins. This is a measure of how warm it is, and it's based on sort of outputs from the sun and everything and other types. And generally, yes, we're looking at transition from cool to warm. Now, originally with LEDs, LEDs are developed generally out of having a blue LED. It was given a special coating to create white light. And at the start, this was a blue-white light. Gradually, over time, they come up with different coatings, and it's got warmer and warmer. And now you have an entire range of different whites available to you on the market. But I think it's quite important to look at what we as humans perceive as warm white and cool white, because sometimes manufacturers look at it and they might be looking at somewhere from 6.5, 7,000 Kelvin. They have that end of the range, and then they go all the way down to a very warm light at 2,500. And what they do is they split it in half, and they say the bottom half is warm white and top half is cool white. So when I'm talking to clients, I often say, if a manufacturer can't tell you the color temperature, it's probably not worth using. This is something that everyone should know. All the LED chip manufacturers publish color temperature details on what they're releasing. And if someone can't be bothered to check the color temperature, sometimes it can be a really big risk to go and specify that on a project. Now, when I talk about color temperature with clients, I'm very much looking at the warm white range is 2,700 to 3,000. When we're talking about general lighting, this is residential and hospitality, we're looking at that range there. Now, you can go warmer than that, but what I try to emphasize is that sometimes people will call 3,200, 3,500 warm white, and I don't perceive that as warm white. I don't treat it like that. So when I advise clients, when I advise students who I teach, I'm saying 3,000 or below, that's where you want to be sticking if you're looking for a nice warm white. And there are a whole range of very warm whites as well. If you want to go down, you want to create that lovely, beautiful candle glow, you could be looking at going down to 2,000 or 1,800 even, which has got a lot of amber in it, very, very warm colors. And it really has to be tailored to the project, but those are a little bit more specialist. Generally, we're looking at 2,700 to 3,000 on a project. It is very much bespoke and tailored to the project which you're looking at. And so when we look at it, we have to check each one. We have to check things like color within the scheme, the style, and what the space is being used for, and that helps determine the color temperature. And that can be quite nuanced in how you go about doing it, and it can mean that you have to do a lot of testing. You have to try it out on finished samples, make sure you get the right color temperature for the space. But it's not just blue and yellow lights. Actually, there's a whole range of different whites out there. Okay, and so what we have here is the Cie Chromaticity Diagram. So this shows all the visual spectrum of light. And what you have on here is a line called the plankton curve, which is this curved line going across it, which is the range of whites going from cool to warm. But as you can see on that, there's a whole range of other colors available. Now, the problem is, and this has become much more apparent with LEDs now, is that you get huge variations in what is produced. Even in the manufacturing process, it's not an accurate process when you go and make LEDs. It's not like you choose to make exactly the same thing over and over. When they do the coatings, there is variation in those coatings. So what can happen is the LED chip manufacturer will produce a huge number of LEDs, and there'll be a whole range of different whites available. And so what they do is they split those down into bins and they group them, matching those colors. And this can cause a bit of a problem, because depending on which bin you buy, that will affect the purity of the white and the kind of white that you're going to be getting. So it's not just warm and cool. There's also the fact that you come off the side of this line and you could get some green or some pink into it as well. So how do we know what we're getting? Well, there's a thing called a macadam's ellipse. A macadam's ellipse is an area on a chromaticity diagram. It varies depending on the area we look at, because our eyes are more sensitive to certain colors and telling the difference between certain colors. Now, within a macadam's ellipse, that is an area that to the human eye, we are not capable of telling the difference between the different colors. Okay, so in that area, effectively, the colors will match because our eyes are not sensitive to determining the difference within it. And that is a macadam's ellipse. Unfortunately, generally you can't make LEDs to fit within one-step macadam ellipses. So what they have done is people are using a growing area and saying our LEDs will match a two-step macadam's ellipse. So it's double the area of the original macadam's ellipse. Or it might be that they say that they go to a 4-step or a 7-step. Now, obviously, within a 7-step, there's a huge amount of variation within that. And this brings us to one of the key issues that you have within the industry today about what products you're going to buy. And this is what can make it quite complex, is that the 7-step macadam's ellipse forms the standard of determination of color temperature. Okay, so within a 7-step macadam's ellipse area, you can have all of it being 2700 Kelvin. And our eyes can tell the difference between all of those. So buying one LED which says it's 2700 and another LED which says it's 2700 is not going to result in matching LEDs. And so manufacturers, or some manufacturers, have taken this further and specifying we do ours to a 4-step or a 3-step or a 2-step macadam's ellipse matching to show that they're doing accurate binning. But what I'm going to talk about here is about how LEDs are, the color temperature is determined by LED manufacturers. I think this gives you a little bit of background about the variation that's on the market, and also helps when you want to interrogate a supplier, if you want to find out a bit more information and work out if the product is good enough, because this is what's going to determine whether or not you get a good product on site and have a good result for your project. So what you're seeing on this diagram here, you're seeing a 7-step macadam's ellipse, and there's a box around that, and you're getting multiple boxes there in different color temperatures, and those are large bins. The red line shown on this diagram is the plankton curve. So you can see the bin spans a section of the plankton curve and it goes left and right of it. Now, when you go and look at different LED manufacturers, they have different kinds of binning. So I'm going to show you an example of binning from one manufacturer. This is from a company called Cie, and they offer a breakdown of their binning. So within each of those large squares, they have 16 bins. And so you can get LEDs within, that's how they will split their LEDs down within those bins. And this is the issue you have with LED manufacturing, is that they go and make these LEDs, they get huge variations, and then they have to split it down into different bins. So it's not like they can choose to just manufacture one of these bins. It has to be split. You take all of them and then divide it up. And this is where you are presented with an issue, is that a manufacturer has made all these LEDs, they need to sell them, and how are they going to sell them? People don't want to buy a whole variation of different LEDs. They want them closely matched, ideally. So what they do is they add price variation to it. So if you're happy to take a wide variety of bins, then you can get a reduced cost. If you want a narrow selection of bins, it's going to cost you more. And so this is where you get that determining factor. Are you getting a good quality LED or a bad quality LED? What are you actually paying for? So to give you an idea, Cie provide two options. This is one of their ranges. They have a huge range of different LEDs, and this is just one of their types of LEDs, but I think it illustrates it well. And I'm just using this as a general example. Cie are actually very good at providing different kinds of matching between their LEDs. So I'm not attacking them, I'm not saying they're doing a bad job. I think it's excellent that they actually publish this information, because this is what suppliers, manufacturers are going to use to go and purchase LEDs from Cie to put in other manufacturers inside their fittings. It's the same with any LED chip manufacturer. So on here you can see two comparisons. On the left we have large bin purchases. This is done to a 4-step macadam's ellipse inside here, and you are getting quite a big range within that area. On the right, what they're doing, instead of having to buy across 16 bins, you can buy across 4 bins, and you're getting, I believe it's a 3-step or 2-step macadam's ellipse accuracy within that space. So you can choose to pay more, and you could go with, say, a Z8 bin grouping, and that will give you accurate color matching across that, or more accurate than if you were to go with an E8 bin. So when people ask me, like, why are these light fittings more expensive? Why am I paying more money? This is one of the major factors. You're having to purchase LEDs at a higher price to ensure good matching. Sometimes you can get good binning, but what will happen is an LED chip manufacturer will supply LEDs further away from the plankton curve. So while you might have good color matching, what you're going to end up with is more pink or green seeping into the white. And it's still going to be 2700. It's just going to have more pink or more green inside it. And you have this line here, which is a CCT, correlated color temperature line, which determines that if you're off on this side here, that still counts as 2700, even though there's a color shift into the green on that side. So you've got to be very careful. You want, ideally, this binning information is available and you can look at what you're being supplied. Or you could even go back to the manufacturer and say, I want to have this particular kind of binning with my products. If you've got a project which is large enough, that should be possible to do. But the key is to be aware of this. This is what the determining factor is on quality of LEDs, or one of the determining factors. So I think it's really important to understand how LED chip manufacturers go about this process, so that you understand what product you're going to get at the end, because it goes through a long supply chain before it gets to the end user. So that's what I wanted to talk a little bit about with color temperature and sort of the determining factors of how you get to a good color matched light source in a project. Next, I want to talk about color rendering. So this is the other factor. This has become much more relevant recently. Now, I always find it complex to explain in words what color rendering is. Color temperature is how warm or cool white is. Color rendering is how well an object is accurately portrayed underneath a light source compared to a standardized light source such as daylight. And this is a good example that I found, and most people are aware of this. This is the changeover in street lighting from sodium lights to LEDs. Now, sodium lights were chosen a very long time ago because they have a very, very high efficacy. So they're very efficient to put into projects, and they have a very long lifespan. They give a good light output, so it's ideal for street lighting, but they have terrible color rendering. So underneath an old sodium lamp, things all look the same color. And you can see in this example, it's all shades of yellows and browns underneath this light source. But when you look at underneath an LED light source, which has better color rendering, suddenly you see the different colors. And people can see this out around them because most cities are going through a transition from sodium lighting to LED lighting on their streets. It is changing how things feel. But this is a good example. This is also, color rendering is what makes people go into changing rooms, try clothes on, they come out, and it looks different outside. And that is because there's poor color rendering in the light sources in the changing room. It doesn't show the colors accurately. So how do you go about measuring color rendering? How do you find out if you're getting a good product? Well, you have to understand LEDs and the existing standards at the moment. Color rendering is measured with a color rendering index. This is a range of between 0 and 100, and it's how closely it matches what's called a black body radiator. This is either daylight if it's above 5,500 Kelvin, or it's an incandescent light source below that. Now, how closely it matches to that standardized source, they measure 15 different colors, and they match across all of those, how accurately it matches. But here comes the nuance of CRI and major complication within the industry in recent times, is that for a long time, the average value has not factored in the last 6 values for CRI. So the R9 to the R15 values haven't been included in this. And so what you're getting is actually just an average of the first 8 colors. And this is determined because of fluorescence, and they originally chose to do this because fluorescence didn't perform very well above R8. And so it was chosen, right, we're going to do a average of the first 8 values. With LEDs are pretty good at color rendering, but there are certain values that they fall down on. And the major one is the R9 value, which is a bright red. And often the R9 value can be terrible. So you think you're getting a reasonable quality color rendering LED if it says its RA is 80 or 85. Actually, it's good on those lower values, but the higher values are really poor. And so what you need to do is find this out. You need to determine whether or not that is going to be good. Now, ideally, manufacturers would publish all this information so that you can see it. Generally, manufacturers who are trying to release good quality LEDs, good quality products, will publish this because it's a good sales point. Others who do not have good quality will not have this information, and it's not required to have this information. So when we do our investigations, when we're looking at different fittings, we'll go and ask these questions. And if manufacturers can't come back with an answer on it, then they might not be getting included in the specification. As a general rule of thumb, when I'm working on projects, anything less than 80 we don't want to use. If you've got an RA value less than 80, it's not really suitable for the kind of projects we work on. If someone's publishing an RA value of 80 to 90, then it's a pretty standardized source. We know that the R9 value is going to be pretty poor. Sometimes the R13 value is going to be pretty poor as well. So we might use this in certain spaces where budgets are concerned or it's not critical to have good color rendering. If you've got something which is 90 to 100, then the color rendering is probably pretty good on that. And then there's a whole variation within that. Hopefully, if someone's publishing that they've got an RA value of 90 or above, they're going to publish all the extra information in technical documentation. And so you can go and dig down into it as well. But this has been causing some problems in determining good products and being able to actually compare good products between different areas. Now, when we look at different color rendering, we have to look at the project. It depends on whether or not we need good color rendering on it. So if you're doing something where you've got to display products, where the finish is important, then we will increase it and we'll make sure we have a really high color rendering index. If it's not critical, or if it's a more basic space or budget is concerned, then we'll go with something which is 80 to 90. And it depends a little bit on the coloring within the space as well. So if we haven't got loads of reds and things like that, we might not push it because there is an additional cost involved in that. And it's whether or not that's going to be possible for the client. There is new developments though within this area. So beyond the CRI value, there is a new standard called TM30. So TM30 takes a much larger range of samples of colors, and some of them can be viewed as more relevant to space. So they're taking samples across this whole range here. And what you're able to do with this is get a more accurate perception of the color rendering. So I've got a little illustration of that. Because you've got all these values with a standard, so you see there's a black circle here. This black circle is sort of a standardized value, the black body radiator. This is the accuracy that you want to get to. And then you can see how a light source falls down on that, where it is not matching that. And so what you can end up with, you can determine if a color is going to be pure, or if it's going to be desaturated, or if maybe it's going to be oversaturated within a space. And you can see here a couple of example pictures which I found, which I think really demonstrate this. So you can see if you've got within the circle, it's going to be desaturated, so the colors are not as vibrant. If it's outside of that, then those colors are going to be enhanced, and they're going to almost, as if you're talking about a photo, they're going to start blowing out on that photo. So ideally, we can match that line, but this is a more accurate method. It doesn't have the flaws of CRI, where people are using an average of the first 8 values rather than all 15. And so this is, a lot of people are moving towards using this as a way of measuring, and it is more helpful. It might become more of a standard in the future. At the moment, though, quite a few manufacturers are publishing details and having tests done to this. But color rendering is important, and but both are important. It's color temperature and color rendering. On projects, sometimes color rendering is very important, but often the color temperature is more of a determining factor within a space. I've got a couple of example pictures here, which I found on the Urco stand at Light and Build. Urco, obviously very famous manufacturer, making a lot of track lighting for galleries. And they had a really nice little demonstration, I thought, which shows color temperature and color rendering. So what you have on the right here, you have a standard RA80 LED and then an RA over 90. And you can see the vibrancy of certain colors there comes out more. The reds, the pinks, the yellows are shown much more vibrant on the high CRI, like illuminated picture. But then if you look at the difference on color temperatures, so the one on the far left is 2,700, the one in the middle is 3,000, and then you've got 4,000. Those are all high CRI photos, but the color temperature dramatically changes how they look and how they feel underneath that picture. So it's very much a case that you've got to consider those together and look at how they work together and what you're going to be doing with them. I think it's really important to factor this both in, and it's a case you've got to look at it on each project and determine each project on a case-by-case basis. But that is my brief overview of color temperature and color rendering. It was short, I didn't want to go on. You can go very in depth, and there is fantastic information out there about this. But I thought this would give a little brief overview, be quite a handy introduction to these very important elements. If anyone has any questions, please put them in the chat box and I'll answer them now. Otherwise, we've got some other webinars coming up soon. Every week it's 10 a.m. On Thursdays. Next week, I'm going to do a Q&A session. So I'm just going to answer questions about lighting design, lighting in general, projects, what we do as a business, our views on certain things. It really just come along, ask some questions, be a free-form Q&A session. On Thursday, the 30th April, what I'm going to do is do a project overview of some of the airport lounges that we've worked on. This is quite a specialist area, and we've been lucky enough to be involved in some wonderful projects which have turned out really beautiful. So I want to give a little overview of how we approach those, talk about how we worked on them, our process going through the design, how we chose to get to the final result. And then we're going to do another one on the 7th of May, but I am still waiting to determine the topic on that. But I will be here for a couple of minutes anyway. If you would like to ask any questions, I will hang around. But thank you very much, and I hope you have a lovely day.